Hello, everyone. How's it going? Can you hear me? Please drop a message to let me know you can hear me. Um, Today, we're going to be doing the DAO tutorial, part 1. So, this is going to be the smart contract part of it. We'll go to hard hat, we'll create a few different contracts, and um, it's going to be really fun. I love this tutorial, and yeah, let me know if everything is working fine, and we shall get started shortly. All right. Cool. Okay. Um, I am going to. All right. I'm gonna get started. Um, cool. Hey guys. So today we're gonna be building part 1 of the DAO. Um, so we will follow along the tutorial. It's part of the sophomore track. If you haven't reached this point yet, you do have to kind of do the previous levels first, as the DAO contract does depend on the NFT level. So we do need the NFT level to be done before you can do the DAO level. And let's just quickly go through what is a DAO before we start. So a DAO is a decentralized autonomous organization. Essentially, it is a community-led entity. It's kind of like a company in the real world, but like on chain, and it's community-led. So traditionally, in a company, if a decision needs to be made, it's the board of directors or the executives of the company who are in charge of making that decision. However, in a DAO, this process is done by the community. So anyone in the community, anyone who's a member of the DAO, can vote on proposals. Uh, Anyone can create a proposal. There's a voting timeline, and then after, if the vote passes or if it gets declined, certain things happen. So typically, membership in DAOs is restricted based on the ownership of certain tokens, be it ERC20 tokens or ERC721 tokens, right? And this is done so that it ensures skin in the game, right? If you don't have stock in Tesla, you don't have skin in the game, and you don't really have any incentive to try and make good decisions for Tesla. Similarly, if you're part of a DAO, well, if there is a DAO, for example, like Uniswap or ENS, it makes sense that you vote based on how much skin in the game you have. So how much share of the total sort of stock or total sort of token supply you have. So ENS and Uniswap are good examples of DAOs which gate based on token ownership, like ERC20 token ownership. And then there's things like Meebit's DAO, where membership is gated by the ownership of an NFT, specifically a Meebit. So today we're going to be doing the DAO level, where we have our CryptoDevs NFTs that we did earlier, and the DAO membership is going to be gated using CryptoDev NFTs, and the NFT holders can create and vote on proposals. And what the proposals will be doing, actually, the DAO we're going to be building is going to be an investment DAO. So the DAO itself is going to be using the money it has to buy other third-party NFTs from a marketplace, and the community kind of decides which NFTs to buy. And this is done so that, like, well, the goal is the DAO makes money, right? So let's just look at the requirements. So the requirements are anyone with a Crypto Devs NFT can create a proposal to purchase some like XYZ NFT from a marketplace. Then anyone with a Crypto Devs NFT can vote yes or no for that proposal. Each NFT you have counts as one vote in the proposal. The same person cannot vote twice, obviously. And if most of the voters vote yes by the deadline, the purchase is automatically executed. So, let's get started. And I'm going to open up my terminal. And so, obviously, we're going to be using Hardhat, right? So, I'm going to create a new Hardhat repo. Let's go to desktop and make their LWB3 DAO tutorial, and I'll go into here. Oops, CD LW3 DAO tutorial. Perfect. And we're gonna initialize a new Node.js project. Oopsie. We're gonna initialize a new Node.js project, and we are going to install Hardhat on here. Nice. So while this installs, I'm just gonna also tell you some limitations of the simple DAO we're gonna make. So currently, well, obviously we don't have time to go through and understand OpenSea's contracts. They're a really complicated set of contracts. So we're going to create a fake NFT marketplace. In the real world, if you were doing this for real, you would probably want to integrate with OpenSea or something like that for the DAO to buy NFTs from. So you actually have like a large selection of NFTs you can buy. But for purposes of this tutorial, we're going to do a fake marketplace we're going to create ourselves. And it's going to be like extremely basic and replicate like an extremely simple sort of secondary NFT marketplace. And we're currently not going to have a way for like if the DAO makes profit, right? You buy a few NFTs, you sell a few NFTs later on. Let's say the DAO makes profit. Currently, there is not a way for that profit to be distributed amongst members of the DAO. The only way you do that is the owner of the DAO withdraws the money and sends it out manually. That's just for the tutorial. There are ways you can do this, obviously. I did a sort of DAO workshop at ETH Global recently. It's pinned on our YouTube channel. There's a playlist there, which was kind of similar to this DAO tutorial, except it had a couple extra things and we kind of speed run through it, as we had like limited time to do the presentation. But this is going to be much more in-depth. If later on you're looking to figure out how do you distribute the profits among all members of the DAO, you can go look at that one and how that happened. All right, so we've installed Hardhat. I'm going to set it up. Do npx Hardhat, create a simple project. Yes. Just going to install a few more dependencies. Am I the one who created NFT puzzle? Yes. How did you hear about that? That's awesome. For those of you who don't know, NFT Puzzle was an old hackathon project of mine. It was a game, NFT based game. We did it like last year, I think. Yeah, almost exactly 1 year ago, 11 months ago, something like that. Um, yeah, I never expected people coming here from NFT Puzzle thing. That's awesome. All right, so our hard hat project is set up. We're going to obviously need to install the OpenZeppelin library so we have access to the OpenZeppelin contracts. And then we're going to start coding. Great. All the packages are done. I'm going to open up VS Code, minimize my terminal, and then let me zoom in a little bit. Oops. Alright. Font zoom in, font zoom in, font zoom in. Alright. I hope you guys can see this. Let me know if this is not super readable still. I will make it even bigger. Cool. Okay, so this is the default contract that hard hat's entered. We don't care about this. I'm just going to delete this file. So, as I said, right, there are three things. Well, there are two things we're going to be creating, two Solidity contracts we're going to be making. One is a extremely simple, extremely basic sort of NFT marketplace, right? And the other is our actual DAO. We need to create the marketplace so I can show the workings of it, and the other is the actual DAO. And the prerequisite is you must have done the NFT collection tutorial from earlier in Sophomore. The articles are obviously all on our website. If you prefer videos, we have a video of it on our YouTube channel. So first things first, what we're gonna do, I'm gonna create a file, fake NFT marketplace.sol, and this is gonna be obviously our fake NFT marketplace. So I'm gonna add the license identifier and the Solidity version just to get started, and we're gonna have a contract. So contract fake NFT marketplace. All right, so let's think about what we need here, right? At the crux of it, really the only thing we need is a purchase function, right? It's a fake marketplace. It doesn't have to be too complicated. We just need a purchase function that takes some ETH and marks the message.sender address as the owner of some NFT, right? This is not even going to deal with real NFTs. It's just going to pretend, oh, we didn't create a folder called Hard Hat Tutorial. You are actually correct. I should follow the way it is in the articles, and I should do that. Thank you for pointing that out. Let me just do that right now. I'm going to create a folder, Hard Hat Tutorial, and I'm going to move everything else. So the README, the contracts, the config file, node modules, package, star, the scripts folder, the test folder, all of them to Hard Hat Tutorial. And we should be good now. All right. Thank you for pointing that out. All right. So, yeah, so we need a really simple purchase function, right? It doesn't do a lot. And the way we do this, if we want to maintain the owner of a specific NFT, we need a mapping, right? We need a mapping to track like uint256 to addresses, which is going to be called, let's say, tokens. Maps token IDs to owners, right? And then, just for simplicity, we are going to set a fixed price for every single NFT you buy from here. So I'm actually going to set it like really cheap, but just for simplicity. Real marketplaces will obviously have different prices for different NFTs. for simplicity reasons, we'll just make them all the same price on this fake marketplace. And all you really do is, in the first function purchase, you take in a specific token ID, right? And you first make sure that the person sent enough money that you were expecting, not enough ETH. And then you make sure that this NFT hasn't already been sold to someone. So you do require tokens, token ID is equal to address 0. So this is going to be the default value, the null address. So you want that it's the null address, otherwise the token is not for sale by this marketplace anymore. So return an error, not for sale otherwise. And then really the only thing you need to do is you update the mapping to say that the owner is now message.sender. So this is the purchase function. And then we're just going to do like a really simple, we're just going to create like a get price function in a real marketplace. This is how you would fetch the price of a given NFT, since our price is fixed. And this is just for like demonstration, right? Since our price is fixed, we're just going to return NFT price straight up. And we will create a function called available that does the same thing as like, is this NFT for sale? And it's going to take in a token ID, and all it does is if tokens token ID has the address 0, then you return true. That means it hasn't been sold to someone else yet. Otherwise, you return false. All right, pretty simple. This is it for the fake NFT marketplace. It's a pretty simple contract, nothing too complicated. Again, a real NFT marketplace would be much more complicated, as not all NFTs would have the same price. NFTs are coming from different sort of NFT collections. And yeah, like their functions will be different, and more arguments and whatever. So just for sanity, let's just check to make sure everything is compiling. So I'll cd into hardhat tutorial, and let's do npx hardhat compile. Perfect. So compiled it successfully. Now let's get started with the fun stuff. Let's do the DAO contract. So I'll create a new file, cryptodevsdao.sol, right? And I need to add the Solidity version and the license. And we're going to create a contract called cryptodevsdao. And also we want this to be ownable. I said earlier that in this video, we don't have a way to sort of distribute rewards amongst the members. So the only way to do that is that the owner of the contract withdraws the ETH and sends it out manually. Again, there is a way to do this. I got into it a little bit at my ETH Global workshop, and you can find that video on our YouTube channel as well. But for now, just following what's on the website, I'm going to create contract cryptodevsdao is ownable. And here's where we will write the rest of our code. Perfect. File outside of opens up Lin directories. Interesting. It's probably because I moved folders, and VS Code did not like that. It should be okay now. Alright, perfect. So we're going to create the rest of our code in here, and we need some interfaces, right? We need some interfaces to communicate with the fake NFT marketplace and our CryptoDevs NFT contract from before. So let's just first create an interface for the fake NFT marketplace. So let's do interface fake NFT marketplace, and we can just kind of take this from here, right? So I'm just going to copy the function header and boom, there's the first function. And then I'm going to copy the second function header. There's the second function, and let me copy the third function header. There we go. That's our interface. So these are all the functions that are available to us in the fake NFT marketplace. And in Crypto Devs NFT, we will be using kind of two functions that we care about. So they're both coming from ERC 721 or ERC 721 enumerable, the contracts that we inherit in Crypto Devs NFT. So the first one is the balance of function that takes an address and returns how many NFTs does this address have. And the second one is the token of owner by index, which lets you kind of loop over all the NFTs that an address has based on their token ID. Or rather, it lets you get all the token IDs that an address owns. And this comes from ERC 721 enumerable, because regular ERC 721 does not have this function. Alright, so we're going to be using these two functions from Crypto Devs NFTs, and these three from the fake NFT marketplace. Also, if at any point you guys have any questions, any doubts, if I say something you didn't understand, put it in the chat. I am looking at the chat. I will try to answer you. But let's go on for now. So, what does our DAO need to do, right? So firstly, we need a way to create a proposal. Then we need a way to vote on a proposal. And this is obviously all like member only. And this is also member only. And then we need a way to like execute the proposal, which would mean actually buying the NFT that the proposal was for if it passed, right? So these are like the three core things we need. So the common thing here is a proposal, right? And a proposal is like a bunch of things pushed together. So we're going to need to create well, we don't need to, but we are going to create a struct for this to kind of make things look a little prettier. So we have a struct proposal, and what goes into a proposal, right? So first thing is you need to track the token ID, the NFT to buy from the secondary marketplace. So we have a token ID of this proposal is to purchase this NFT, right? And then we want to track a deadline. So when does voting end? Then obviously we want to track the number of votes, so number of yay votes and the number of nay votes. So this is like yes and no votes. And for execution, we're gonna track if the proposal was already executed. And lastly, we are going to track a list of all the voters. More specifically, we're actually going to track like which token IDs have been used for voting already. So this is like token ID to Boolean. Cool. Now, other than the struct, we are going to maintain a mapping from UN256 to proposals, which is going to keep a track of all the proposals. So this is kind of like proposal ID to proposal. And we are going to track the total number of proposals that have been created within the DAO. Alright. And then, obviously, since we're going to be calling these two contracts, we need a reference to the two contracts. So I'm going to add a I fake NFT marketplace, and then an I crypto devs NFT, and we'll use these to call functions on the other smart contracts. All right. So in the constructor, really the only thing we need to do is initialize these two variables. So we'll create a constructor that takes in two values, right? So first is like an NFT marketplace address, and then a CryptoDevs NFT address. And we're just going to set it equal to, so NFT marketplace is equal to I fake NFT underscore NFT marketplace, and similarly CryptoDevs NFT equals I CryptoDevs NFT underscore CryptoDevs NFT. All right. And one more thing we're gonna do actually is we will mark this function as payable. We'll mark the constructor as payable. So when the DAO is first created, we can send it some ETH. And that's the ETH it's going to use as like its treasury to start off with. And it can use that ETH to then like buy NFTs from the marketplace. So think about it. The storyline goes like this, right? You're a person who just launched an NFT collection, right? It was successful, it sold out, great job, you have money, and now you need to please your community, right? You do the ICO, you give out free tokens to all the NFT holders, and then like from those two things, you have a bunch of ETH, right? You have a bunch of ETH that you want to put to use somewhere, and you want to give the community power. So you start this DAO, and you put a bunch of the ETH that you earned into the DAO, and your community kind of then votes on, okay, like, oh, we should also buy a Bored Ape, or we should also buy a Doodle, we should also buy a CryptoPunk, right? And then proposals happen, and you buy all of those NFTs, and maybe sometime later, with some improvements to this contract, you could have had a sell function, right? So like maybe like 6 months later, you're like, oh shit, we made like 3 times profit on some NFT. Let's sell it now, and then let's take the profit and split it amongst everyone in the community. And that's kind of like the storyline here. That's kind of what we're trying to show off through this interconnection. So Yash is asking, other than NFTs, are there any options we can use to implement for voting power? Well, the most common way is to do it based on tokens, like ERC20 tokens. So things like ENS or Uniswap, based on the number of tokens you have, that is your voting power. But we thought NFTs were more fitting in this sense. But yeah. All right. So NFTs in this case were just more fitting for the storyline, but you can do it with ERC20 tokens. Cool. So the constructor is fine. And then the three functions are member only, right? So like that's something common within them. So I'm going to create a modifier called we'll call it NFT holder only. And what this does is it makes sure, so membership currently is defined by ownership of a CryptoDevs NFT, right? So we will require that we'll call the balance of function for this message.sender, and it must be greater than 0. So they must have an NFT to like do any member only things in the DAO, right? So we have the modifier, we have the struct, we have a mapping to keep track of all proposals, and we have the sort of member only or NFT holder only struct available to us, modifier available to us. So now we can get started writing our create proposal function actually. So function create proposal, given 256, NFT token ID, and this is going to be for NFT holder only, of course, and we are going to return the freshly created, the ID of the newly created proposal, right? So it returns ID of newly created proposal, and the parameter underscore NFT token ID refers to the NFT you want to buy from the fake NFT marketplace. All right. So what do we need here? We need to do a couple of things. The first thing you need to check is that the NFT marketplace actually has this thing for sale, right? It's not like it's already been sold to someone. So NFT not for sale, right? This thing you want to do, and then if it is available, you can go ahead and kind of create this proposal, right? So we're gonna load up a proposal from our mapping, and the ID is going to be num proposals. So what does this mean, right? So the initial value of num proposals is 0, right? When the contract is just deployed, it's 0. So the first proposal that gets created gets the ID 0 because we load up proposal 0, and we're gonna save some information here. So the first proposal that gets created gets the ID 0, and then after we do some things with the proposal over here, we are going to increment the number of proposals, and then the next proposal that gets created will get the ID of 1 and 2 and 3 and so forth, right? So the things we actually need to save in here, well, we obviously want to track the NFT token ID, right? And we will automatically kind of set the voting deadline to be the current timestamp plus 5 more minutes. All right. Obviously, in real life, the voting period lasts for like days or sometimes weeks, but we want to test, right? You don't want to deploy a contract and wait for like 1 week to see if it worked or not. So we're going to set a deadline to be just like 5 minutes from the time the proposal was created. And all of the other values in the struct, we can let them be the default values, because yes votes, no votes, the default value for this is 0. So we can let that be 0. The executed default value is false. We can let that be false. And nobody has voted yet, obviously. So we're just going to let the mapping be its default value as well. And then we want to return the ID of the newly created proposal. So the ID of the newly created proposal was num proposals, but then we incremented it. So we actually want to return num proposals minus 1 at this point because we incremented it. And then this will send back the new proposal ID to the front end or whatever, right? Cool. Now it's time for voting. Now, in voting, obviously each member can vote 1 or 2 ways, right? Like either you vote yes or you vote no, right? So what we want to do, and we don't want them to like try to put in any garbage values or random things. This is a good use case for an enum, right? So I'm going to add an enum over here that's going to have 2 types of votes, so yay and nay. And in our vote function, we will just take an enum value, so it can only be one of 2 things. So you create a function vote on proposal, right? And this is going to take 2 things. The first thing it needs to take, it wants a proposal ID. Which proposal are you voting for? And then it will take a vote. Are you voting yes or no? And this is also going to be member only, right? And the other thing we want to make sure here actually is this proposal actually active? Right? If a proposal's voting time has passed, it's in the past now, well, obviously you can't vote on it anymore. So I think you can add a require statement here, but in the tutorial we created more modifiers just to get you people more comfortable with using modifiers. So I am going to add another modifier here called active proposal only, right? And this is a modifier that takes in an argument, let's say proposal ID, and essentially what it does is it requires that from the proposals mapping, this specific proposal's deadline should not have passed, so it should be greater than the current block timestamp, otherwise proposal inactive, right? Or rather like Yeah, proposal inactive. All right. Hey everyone, I see a bunch of new people joining. Hello, how are you? We're doing the DAO tutorial from Sophomore, so good to have you guys here. All right, so we have the active proposal only, and in fact, while we're at it, we're gonna need this later. So might as well just create another modifier for inactive proposal only. So for example, execution of the proposal can only happen after voting is completed. So for that, we will have an inactive proposal only modifier, which behaves somewhat similarly. So it takes a proposal ID and it checks for two things. It checks that the deadline has already passed, right? So either it is less than or equal to the current block timestamp. Otherwise, you say proposal, like proposal still active, right? And then we do proposals, and we also want to make sure it hasn't already been executed, right? So we make sure that executed is false. Otherwise, we give an error, already executed, and then we send it on its way. All right, so we created a couple more modifiers. Let's go back down to our vote function, and then we are going to mark this vote function as active proposal only, and we are going to send it forward the proposal ID. All right. Now we have checked these two things. We've checked that the function caller is a member. We've checked that the proposal is active. What else do you want to do? I mean, we don't need any more checks. We already checked that from our modifiers. So we just load up the proposal struct, right? We figure out how much voting power this guy has, whoever the person is calling it, right? So voter NFT balance, and this is going to be coming from the NFT contract. So we check the balance of message.sender. Now to explain the next bit of code before I get into it, let me kind of give you the intuition for why we're going to do what we're going to do. So imagine you have this voter NFT balance, right? Let's say like it returns 2. You have 2 NFTs. And then you vote. So let's say you vote yes, 2 yes votes get added to some proposal. But then before the voting completes, you go out and you buy a third NFT from someone else. Now you want to use that third NFT to vote. But you can't. Because, well, if we are, how would you know, right? So what we want to do is, if someone's balance is a certain amount, it doesn't mean that they're voting specifically like for that amount, right? Like my balance would have been 3, but I only have 1 more vote remaining. 2 of my votes have already been used. So we're going to need to sort of loop over how many NFTs this person has and check if that specific NFTs have been used for voting yet. Tushar is asking, when will you record DeFi exchange? So the DeFi level is right after this one. Well, this is DAO tutorial part 1. There will be a part 2, which will be the front end for it. And after that, we'll get into the decentralized exchange stuff. Yeah. Cool. Anyway, so we want to kind of figure out how many votes the person has, right? Like actually left. So we're going to keep a variable called number of votes, and we're going to loop over all their NFTs. So the way we do that, we loop over their balance, and we get the token ID from token of winner by index, message.sender and index. So this will give us a specific token ID. So like the first token ID, the second token ID, third token ID, whatever. And then we check that if proposal voters token ID is false, if this specific NFT hasn't been used for voting yet, then we count it as a real vote, and we also mark it as having used for voting now. All right. When we have these things, what is going on? Proposal.voters not found. What? It's stupid. It's literally right there. Is this just hard hat bugging out? It's probably just hard hat bugging out. It doesn't give an error on the same line, 2 lines above. Just gonna reload. Alright. While this reloads. Okay. So we figured out the actual number of votes, right? Oh, I typed proposals. Sorry. Should be proposal. Alright. You want to make sure that the person actually has more than 0 votes, otherwise they just wasted gas for no reason. But we want to at least send them back whatever remaining gas they have left. And then depending on what kind of vote they did, so if they voted yes, we will increase the yay votes on the proposal by number of votes. Otherwise, we will increase the nay votes on the proposal by the number of votes. Alright? This is the vote proposal function. So let's kind of recap what happened. So if you're a member, and if this proposal ID you want to vote on is active, then we get your NFT balance. We loop over all of your token IDs and figure out how many actual votes you have left. And then we apply those votes to whatever direction you kind of specified you want to vote for, right? If you want to vote yes, we apply them to the yay votes. If you want to vote no, we apply them to nay votes. All right. Now for execute proposal. All right. So this is like, I actually want to show you guys a few of my slides that I created for ETH Global, so you guys have like some intuition for why this is why are we doing this. Let me just give you, for those of you who haven't seen it, I'm just going to show you a couple of slides really quickly. So what we're doing here is we're actually building a DAO on chain that has automatic proposal execution, right? What does that mean? Well, I kind of talked about what is a DAO, but the types of DAOs that exist today, there's like MakerDAO and Moloch DAO here on the left, which are completely on-chain proposals, voting, everything happens on-chain. But then majority of the other DAOs are off-chain, right? And they live on like regular kind of like Web 2 platforms, and like voting and proposals happens on Web 2 platforms. They're still like token gated. The website sort of token gates them. It's not like fully Web 2, but there are no smart contracts involved in the voting process. That's what I mean by off-chain voting. So what does this lead to us? This is kind of a sad reality. This is not the ideal vision for DAOs. The problem, well, the good parts and bad parts, right? So the good part of an off-chain DAO is, since it's off-chain, there is no gas, right? When you vote, you don't have to call a contract function. It doesn't cost you any gas. So it might get more voters, right? It's easier to get involved. But the cons are, since it's off-chain, you need to rely on the team or like a specific wallet to actually like execute a proposal after it has passed, right? Because it doesn't happen just automatically. You need someone to go ahead and do it, and that someone is the team, the person who created the project. And the problem with that is we've recently been seeing cases where a proposal that passed heavily on like an off-chain voting platform didn't get executed, because the team didn't want to execute it. The team didn't want that to actually happen. So even though a bunch of people voted yes and the proposal passed, the team just didn't do it, right? What are you going to do? So you need to trust the team to actually do it. And it's just like, you might as well just conduct a poll in your Discord server, I think. Now, for an on-chain DAO, the good part is there's no need to trust a team or a wallet to execute the proposal. And all the votes, all the proposal, everything, all actions are on-chain and verifiable. But obviously, the cons are it will cost gas to vote. And general purpose DAOs where proposals can do arbitrary stuff, not just buy an NFT, can be a little complex to code up. All right. So this is all the slides I wanted to show you, but hopefully you have some intuition on why we're doing what we're doing. So for execute proposal now, this is the execution part. This is where if a proposal passes, we are going to let any member of the DAO, not just the owner, we're going to let any member of the DAO come in and execute a proposal on which voting has finished. All right, so now you no longer need to trust on a single team member or a single person at all. You can go and execute the vote yourself if you're a part of the DAO, right? And you can only do this on inactive proposals, so that means that voting must have already been finished. And so we've checked that the person calling it is a member. We've checked that the proposal is inactive. It means the deadline has passed and voting is concluded. So we're going to load up the proposal from our mapping. Proposal ID. And we want to check did the proposal pass, I guess, right? And the way we're going to check that the proposal passed, and this is a really simple implementation. Real DAOs, you might want to get a little more complicated with it. So all we're going to do is we're just going to check if it had more yes votes than no vote. No vote. Tushar is asking, so are we going to make the one which don't cost gas? No. We are creating an on-chain DAO. It will cost gas to vote. You will have to call the vote function on here. But the point isn't about gas here. That's not the problem we're trying to solve. The problem we're trying to solve is having to rely on someone to execute the proposal, right? If you want no gas voting, just go to Snapshot and set up your DAO there. And that's all fine, right? You might get more voters that way, but I mean, why is it decentralized? Why do you call it a DAO? I don't know, it's weird. It's not really like, it comes back to that one person or that one team. You need to trust them to actually execute proposals. So, I don't know. We're trying to solve for the trust problem, not the gas problem. And gas is a non-issue in my opinion because we have so many layer 2s now. You don't need to do this on mainnet. You can do this on layer 2s, and it's really not that expensive to use a layer 2, guys. You can do like hundreds of transactions in like $1 of crypto. Alright, so if the proposal passed, we're doing a very simple check. If yes votes was more than no votes, you may want to do something more complicated if you want to like extend this idea out. Maybe, so sometimes DAOs would have things like a minimum number of members must have voted. So just because one person voted and 1 is greater than 0, it doesn't mean the proposal should pass. Maybe you want like at least like 20% of all members to actually vote. You could do that. Or maybe you want like instead of a 51% win, this is essentially a 51%, right? So instead of 51%, maybe you want to do like 66% based sort of proposal passing or not. But in this case, if the proposal passes, we're going to get the price of the NFT we want to buy. Obviously, we know the price because it is like a fixed value, but just to kind of replicate a real marketplace feel. We're going to fetch the price of an NFT, and we want to make sure that our contract has enough ETH to pay for that NFT. Otherwise, we give an error, not enough funds at the moment. And then if we do, we are going to call purchase on the NFT marketplace, send it some ETH, which will be equivalent to the NFT price, and then call it for the proposal.nft token ID. So that is the NFT we want to buy, right? And then we will mark the proposal executed as true. All right. So the proposal didn't pass. You don't buy anything. You just mark it out. Okay, it's executed. It's done. But if the proposal did pass, then you want to like buy the NFT and things, right? Lastly, since I mentioned we're not going to be redistributing funds amongst the members at the moment, I do have a video on it. Again, it's on our YouTube on the ETH Global workshop, which is much more sort of fast-paced and more intense, and I don't show all the code live on video. I had some like pre-written code, and I just kind of walk through it. So for now, we are going to have a function called withdraw ether that is only callable by the owner. And I know this goes against what I was like talking about right now, right? Like, oh, you don't want to trust a single team person. I know, like, okay, you have an only owner function to spread the profits, but it would have become like a little bit complicated if you did all of that. Even in the ETH Global workshop, I didn't write all of that code live and I didn't give it out. Maybe we will update the tutorial on the website to have this. But for right now, I kind of want to follow what the website says. And if you're interested in sort of automatic profit distribution amongst the members, you probably want to go check out the workshop we did at DAO Hacks. But cool. For now, we're just going to take the owner address and send it all the money that the smart contract has. And obviously, it's an only owner function, right? And last but not least, we're going to have some sort of fallback function so people can send ETH to the DAO if they want to fund its treasury, if they want to help donate to our cause of buying NFTs. All right, so this is it for the DAO contract, right? Obviously, we need to deploy it still. So let's get started on the deployment scripts and stuff, but this is it for the contract. So we have a way to create a proposal, vote on a proposal, execute a proposal, and then the owner can sort of withdraw the ETH and spread it out amongst members if he wants to. And then we have like fallback functions so the DAO can accept ETH from you. Cool. And then what we want to do is I'm going to install .env so we can work on the deployment scripts. And then while this installs, I'm going to go and create a .env file inside my hard hat tutorial folder, right? And the .env file needs two things. So Alchemy API key URL and a Rinkeby private key. So here you would put in something like HTTPS, Rinkeby dot whatever the URL is, and the private key is like whatever, right? I'm gonna do this off screen, so I don't want to leak this to you guys. I'm gonna do this off screen real quick. So let me just grab these values from my Alchemy dashboard and my MetaMask. All right. Give me just 1 second. I'm just copy pasting my private key. Last time I disclosed my private key on stream, just because it was a fake account and I didn't care about it. I disclosed my private key on stream, and somebody kept stealing all my test ETH. That wasn't fun because I constantly in the live stream had to go to the faucet and keep requesting new ETH so I could show how it was working. So Yash is asking, what if by the time the proposal gets executed, the NFT we were looking for has already been sold? Well, in that case, the proposal will not be executed, right? And I'll show you why in just a second. Let me just copy over my private key real quick. All right. So I added my environment variable, but okay. So let's say a proposal passes. You call execute proposal on it. Execute proposal will try to purchase it from the fake NFT marketplace. But the fake NFT marketplace will throw an error saying it's not for sale, right? I mean, it's not really anybody's fault, right? You can't really like book an NFT for yourself. If somebody else buys it, like you can't really do anything about it. So at that point, the proposal is just, it's a zombie proposal. Nothing will happen to it. It's just done. So yeah, can't really do anything about that. That's just hard luck. All right, so I've added in my environment variables, and let us go create a deployment script. So under the scripts folder of hardhat tutorial, create a file deploy.js, right? And I'm gonna do like import ethers from hardhat. Sorry, I don't really use JavaScript a lot day to day, and I always get confused on how the require syntax is written. I just do import in TypeScript all the time. But okay. So we have an async function main, and the deployment script will be calling main. Right, so if it succeeds, you process exit with system code 0, which is successful, and if it errors out, we will print the error, and we will process exit with the system code 1, which signifies that an error happened. So in the main function, we want to first actually deploy the fake NFT marketplace, because the DAO needs the address of the fake NFT marketplace to work, right? So we'll first grab the fake NFT marketplace. So ethers.get contract factory, fake NFT marketplace, right? And then grab a specific instance of it. Equal await fake NFT marketplace.deploy. And then we will await fake NFT marketplace deployed. We'll wait for deployment to finish. And then after the fake NFT marketplace has been deployed, we can print out its address. So let's say fake NFT marketplace deployed to that address. All right, and then now we can deploy the DAO contract. So but the DAO contract needs one more thing, right? The DAO contract, it needs the NFT marketplace address. It also needs the CryptoDevs NFT contract address, though. So for that, I'm going to create a, what's it called? I'm going to create a, constants.js file, right? And in the constants.js, I'm going to do const CryptoDevs NFT contract address equal some string, and then module.exports CryptoDevs NFT contract address. All right, we'll fill this in. This will allow us to kind of import this, right? So you can do const CryptoDevs NFT contract address, equals require /constants. So we now have the CryptoDevs NFT address. We have the fake NFT marketplace address. We can deploy the CryptoDevs DAO equals await ethers.get contract factory, and the name of the contract is CryptoDevs DAO. And then we will deploy it, right? CryptoDevs DAO.deploy, and it takes a few constructor arguments, right? The first argument it takes is the address of the fake NFT marketplace. Then it takes the CryptoDevs NFT contract address. And then since our constructor is payable and our DAO needs some ETH to work with to like buy NFTs from the marketplace, we will just start off by sending it some ETH. Let's say like 0.01 ETH. And it can buy 10 NFTs with this because we set the NFT price to 0.001. If you don't have this much ETH, change this value to something else. That is totally fine. It's just for show. And then we will wait for this deployment to finish. And then we'll do console.log CryptoDevs DAO deployed to CryptoDevs DAO.address. Alright. Makes sense? So we first grab the fake NFT marketplace, we deploy it, grab its address, and then we deploy the DAO with the fake NFT marketplace address, the NFT contract address, and we send it some ETH to start off with. Alright. Last thing we want to do is we need to set up our hard hat config. So get rid of this task from here. We don't need that. We want to set up .env. So we want the .env package to go ahead and read our env file. And then we want two things. So we have an alchemy API key URL equals process.end.alchemy API key URL. And then we have our Rinkeby private key, process.end.rinkeby private key. Alright. And in the hard hat config, we're just going to add it as a network. So networks, Rinkeby, give it the alchemy key URL API, and give it one account, which is just going to be our Rinkeby private key. Great. As for the constants, the NFT contract address, you guys should put your own NFT contract address here, because otherwise you will not have NFTs from that address that you can use to vote in the DAO. I'm going to put one that I have in here. And alright, sanity check. Let's do npx hard compile. We've been writing code for a while. Great. It compiled. Nice. And that's about it. This was actually really smooth. I expected this to take longer. We barely crossed an hour. We're not going to do the front end part today because the front end part is going to take some time. But just to show you, I am going to try to deploy it on Rinkeby, but we will get back to this when we're doing the front end. But let's just try to run the deployment script and see what's up. Alright, so the fake NFT marketplace first got deployed to this address over here. And then we're deploying the DAO contract now. There we go. So deploy the two contracts, and then we can do things with it. I'm going to leave it at that for today. We're going to do the front-end Next.js in a separate tutorial because that's going to take time. I don't want you guys to be sitting here for 3 hours. So this is the smart contract. I'm gonna hang out here for about 5-10 more minutes. If you guys have any questions, I'll answer any questions. Is there any other project you suggest that we should do in DAOs after the sophomore level? You mean like how you want to build like more DAOs? You build like better DAOs? I would suggest taking a look at the ETH Global Workshop. Just because like the ETH Global Workshop actually like implements not just buying NFTs but also selling it back to the marketplace, and it also implements automatic profit distribution amongst all members of the DAO. At some point, I will probably update the actual DAO level in the sophomore track to have those things. So like it's better suited, and you're not trusting a single owner to withdraw ETH and split it fairly. So I'll probably update the sophomore track to have that level directly at some point, and also probably redo this video. But in the meantime, the ETH Global video is on our YouTube channel. So if you go on our YouTube, there's a section LearnWeb3 at events. There's a playlist called LearnWeb3 at events, and there we have our ETH Global Workshop that you can check out. I think that's mostly the same thing, right? Like it's probably like 90% this exact contract, but with like a couple extra functions and a couple extra things in there. I just don't want this video to include that at the moment, just because people are going to be coming here from the website, from the tutorial, and it would be weird if the tutorial and the video have two different things going on. But yeah, once we update to having that directly on the tutorial, I will probably recreate this video and re-upload it on the YouTube. Great. Alright. Well, I'm gonna be around for like 4 more minutes until 11:15. It's 11:11. Make a wish, and then at 11:15, I'm gonna rug this space, rug the live stream, and feel free to ask me any questions on the Discord afterwards. Great. Dark mode. Oh no. Ditya is asking, will I be qualified to be called a Web3 developer after completing the senior track after launch? Well, I think so. Um, I mean, obviously, we're going to have more content coming out even after the senior track, but that is more focused on you trying to find a niche and then getting really good at it. What we have from kind of freshman to senior, it covers a lot of content material where we cover NFTs, DAOs, DeFi, ICOs. If you once you get into junior, we cover like Chainlink, the Graph, ENS, Radical. We cover like 100 different things and sort of like just like 4 tracks, right? And obviously we don't have enough time to get like super deep into them. We still try to go like deep enough that you actually understand what's going on, but we don't always consider all the edge cases or all the alternative solutions or different things that could exist. So I feel like after senior, you're definitely way ahead of the curve, and you're definitely at a point where you can start calling yourself a Web3 developer, I think. Um, Content that comes after senior is going to take a specific topic, right? So, for example, like decentralized identity or like zero knowledge proofs and like Ethereum scaling or whatever. It's going to take like specific niche topics, and we won't tell you to go do all of it, right? Freshman to senior, we kind of tell everyone to go through those 4 tracks to build up their background knowledge, especially if they're new. The later on tracks, you'll kind of go and do what you want to do based on personal interest and where you want to end up in the blockchain space, right? Like maybe you're interested in cryptography and you want to go learn cryptography and Merkle trees and zero knowledge proofs and yada yada yada. Or maybe you want to do like decentralized social media and you want to go into decentralized identity and things like that. Or like all sorts of different things, right? And in those tracks, we'll take those topics and do an extreme deep dive into it, because then the entire track will be focused on this one single topic. And that kind of depends on like the way we think about it is that the 4 freshman to senior tracks were created to kind of obviously give you the background knowledge you need and also kind of open up your mind a little bit to the potential of this technology, like all the 100 different things that are possible. But once you know all the 100 different things that are possible, hopefully you have some idea of what you're interested in, right? Maybe you're still not completely sure. Maybe you still want to try out multiple things, but hopefully there's like something that stands out to you a little bit more than others. And then you take that topic and you go really, really deep into it. And you basically become like an expert in that topic, in that field. And then like you are a Web3 developer who's like really, really good at something, right? So for example, like Snay is really good at like security stuff. I'm not that great at security stuff. I'm more into like decentralized identity. That's my niche. So yeah, content after senior is kind of focused on niche areas, and what you want to do depends on your personal interest. We'll not say that everyone needs to go through every single thing in there. Freshman to senior, we kind of do say everyone should go through everything in there. But yeah, hopefully that answers your question. Cool. Malcolm asks, can you start learning Web3 without knowing any coding at all? I mean, yes, right? Like, anything is possible, like, sure, you can do it. Is it going to be an easy journey? Probably not, because, well, you do need to learn traditional programming and, like general programming concepts, general programming fundamentals. You need to have some Web2 knowledge to get started. So you can do that parallel to learning Web3, right? You can kind of learn JavaScript and then learn React, web dev, all of those things in parallel to learning Web3. People have done it. I know people in the LearnWeb3 community who have done it and have done it successfully to the point where they are now like working like professionally. But I mean, obviously there's challenges. So I just want to say like there are some challenges to it, right? So, but yeah, join the Discord. If you're starting, I suggest you go to LearnWeb3.io, head over to the freshman track, right? And then head over to the first level, basic programming. And basic programming is kind of a curated list of resources we provide. These are all free resources, and you can go here and get started learning like basic programming things if you're absolutely new and have never coded before. And once you kind of feel comfortable in these things, you can go ahead with the rest of the track, which starts off from what is a blockchain, right? And then just proceed. So join the Discord. People will be happy to help you. I will be happy to help you. Ask any questions you have in the appropriate channels on Discord. And yeah, I mean, people have done it. It's possible. Cool. I've been here longer than I said I will be. So I'm gonna... oh, I can play this game with my mouse? I did not know that. What the hell? This is so much easier than using a keyboard. What? That's awesome. Alright. I've been here longer than I said I'm going to have to. So I'm going to hop off. If you guys have any more further questions, post them on Discord and I will be keeping an eye out. And hope you guys enjoyed the stream. Thank you. Thank you to everyone who came. See you. Have a good day.